What do we mean by the term allotrope? Allotropes are different forms of an element which have different physical properties but identical chemical properties. Different allotropes of the same elements have different arrangement of the atoms. Carbon exists in both crystalline as well as the amorphous forms. There are three important crystalline allotropic forms of carbon: diamond, graphite, and fullerenes. Diamond, the first allotrope of carbon, is the hardest substance on Earth. Diamond has a crystalline lattice in which the carbon atoms are arranged in a rigid three-dimensional network. In diamond, all carbon atoms exhibit sp3 hybridization. Each carbon is bonded to four other carbon atoms situated tetrahedrally around it. The CC bond length is 154 picometers. This directional network extends in space and produces a three-dimensional network of carbon atoms as shown in the illustration. Try to answer this question yourself before proceeding. The carbon atoms in diamond are covalently bonded. Why is the melting point of diamond very high? Recall that each carbon in diamond is attached to four other carbon atoms surrounding it. It is very difficult to break up this covalent network as it is very rigid, and hence diamond melts at an extremely high temperature. Since there are no free electrons in a diamond crystal, it is a bad conductor of electricity. Another important allotrope of carbon is graphite. You are probably the most familiar with this form of carbon for its use in pencils. Despite the name, pencil leads are actually made of graphite. Graphite has a layered structure. These layers are held together by the weak van der Waals forces of attraction. The distance between any two successive layers is 340 picometers. Each layer of graphite is made from planar, hexagonal rings of carbon atoms as shown in the diagram. All the carbon-carbon bonds are 141.5 picometers in length. Each carbon in graphite is sp2 hybridized. Each atom forms 3 sigma bonds with its 3 neighboring carbon atoms. The fourth electron of each carbon is involved in pi bonding, using the unhybridized p orbital on each carbon atom as shown in the illustration. The electrons involved in the pi bonding are delocalized. This means that they are free to move, and thus graphite is a good conductor of electricity. Try to answer this question on your own before proceeding. Why is graphite soft and slippery? The layers in graphite are held together by the weak van der Waals forces of attraction. Thus, the layers slide past over each other and break off easily. When you take notes with your pencil, you leave layers of graphite behind on the paper. The third important allotrope of carbon, the fullerenes, are the most recently discovered. They were identified by Robert Kerr, Harold Kroto, and Richard Smalley in 1985. For which they were awarded the 1996 Nobel Prize in Chemistry. Fullerenes can be prepared by heating graphite in an electric arc in the presence of inert gases. This work led to the discovery of the two most important fullerenes. Molecules containing 60 and 70 carbon atoms, respectively, plus traces of other fullerenes. Fullerenes are cage-like molecules. C60 or Buckminster fullerene, named after the American architect famous for his geodesic dome structures, looks like a soccer ball. It is sometimes referred to as a buckyball. Buckminster fullerene contains 60 carbon atoms arranged as a hollow sphere. This ball-shaped molecule has 60 vertices, each occupied by a carbon. It contains 20 6-membered rings and 12 5-membered rings. A 5-membered ring is fused with only 6-membered rings, while a 6-membered ring is fused with 6 or 5-membered rings. All the carbons in the Buckminster fullerene molecule are sp2 hybridized. Each carbon atom forms 3 sigma bonds with its 3 neighboring atoms. The remaining electron in each unhybridized p orbital of carbon is delocalized in molecular orbitals, giving the aromatic character to the molecule. 2 different bond lengths are observed in Buckminster fullerene. The carbon-carbon single and double bond lengths, as observed in C60, are 145.3 and 138.3 picometers, respectively. Each carbon atom forms formally 2 carbon-carbon single bonds and 1 carbon-carbon double bond. Under standard conditions, graphite is the thermodynamically most stable allotrope of carbon. Since it is considered as the standard state of carbon, its heat of formation is set at 0. Both diamond and fullerenes have higher heats of formation, reflecting their lower stability. The heat of formation of diamond is 1.90 kJ per mole, and the heat of formation for fullerene is 38.1 kJ per mole. The amorphous forms of carbon include carbon black, coke, and charcoal. Carbon black is formed by burning hydrocarbons in a limited supply of air, or by incomplete combustion. It is an almost pure form of amorphous carbon containing 98 to 99% carbon. Coke is formed when wood is heated at high temperatures in the absence of air, which is called the destructive distillation of wood. To form charcoal, coal is heated at high temperatures in the absence of air. Carbon has a wide variety of uses in its elemental forms. Diamond is widely valued in jewelry. They are measured in carats. 1 carat is equal to 200 milligrams. Diamond, both natural and synthetic, is used as an abrasive in sharpening tools, die making, and in the manufacture of tungsten filaments for light bulbs. Graphite is used as a dry lubricant in machines running at high temperature where oil cannot be used. Graphite is also used to make strong and lightweight composite material for tennis rackets, fishing rods, aircraft, and canoes. Being a good conductor, graphite is used to construct electrodes for use in batteries and in industrial electrolysis. Crucibles made of graphite are inert to dilute acids and alkalis. Activated charcoal is very porous and can absorb many times of its own volume of gases. It is used for absorption of poisonous gases, removal of organic contaminants from water, and for odor control in air conditioners. Carbon black is used as a black pigment in black ink and as a filler in automobile tires. Coke is used as a fuel and as a reducing agent in metallurgy.